Hey, TylerTech here. So right now this phone is falling. It was dropped from a drone that is flying over the high school, and if we are ignoring air resistance, this phone should be accelerating towards the ground at a rate of exactly 9.80665 meters per second squared, according to Wikipedia. That is because gravity is pulling down on this phone at a rate that is measured to be 9.80665 meters per second squared, and we also are assuming that there aren't any other forces acting on the phone. So that means things, including this phone, fall down. But how do we get an accurate measurement of how fast things accelerate downward because of gravity? So before I give that answer, give me a second to get out of here before this phone hits the ground. Now that I'm out of that phone, let's get back to physics. So the accepted value for gravity, as I said earlier, is 9.80665 meters per second squared, and that's all according to Wikipedia. But one way to calculate the force of gravity on Earth is to use Newton's law of universal gravitation. That formula is this. So the acceleration due to gravity is equal to the gravitational constant times the mass of an object over its radius squared. So the gravitational constant is a constant that has been verified by observation and experiments and is used by Newton and Einstein for different theories and laws that involve gravity. So if we use the Earth as our object, the mass of the Earth is 5.972 times 10 to the 24th kilograms, and the radius of the Earth is 6.371 million meters, according to Google. And the gravitational constant is equal to this mess. So when you plug all of that into a calculator, you get 9.81364678 meters per second squared for the acceleration due to gravity on the Earth. So if you think back to the accepted value of gravity that we got off of Wikipedia, the value that we just calculated is about 7 thousandths off of that. So if one method is off by that much, what is the most accurate way to measure the acceleration due to gravity on Earth? Today I want to take a look at a few methods to measure the acceleration due to Earth's gravity and figure out which way gets the closest to the accepted value of 9.80665 meters per second squared. We're going to look at a few different methods, but I want to note up front that I think the third method that we're going to look at is going to be the most accurate, and I'll explain why a little more in depth just before we take a look at it. So what we're going to do is we're going to find the acceleration due to Earth's gravity using a method. We have 4 different methods in this video that we're going to take a look at, and then after we measure the acceleration due to Earth's gravity with that method, we're going to compare it to that accepted value that we got off of Wikipedia, which once again is 9.80665 meters per second squared. So we already took a look at the first method, which was using Newton's law of universal gravitation, and it was off by about 0.007 meters per second squared, and that's most likely due to the measurements for Earth's mass and radius that we used. So there isn't necessarily a very accurate way to measure those because of the size of the Earth, and there's also a variation in the radius of the Earth depending on where you are, since Earth isn't a perfect sphere. Up next, let's take a look at another method which is probably the simplest to actually do. You've probably even done it in your physics class already. So we're just going to drop objects and measure their acceleration downward or their acceleration due to gravity. So all of the methods that involve experiments are going to be done 5 times and then averaged. So let's get started with this. First, we're going to take an object and drop it from a height of 1 meter. The object I used was a flash drive that I had lying around. So we need to measure the time it takes to hit the ground. I did that 5 times, as you can see on the screen here, and I ended up with 5 different times, and I averaged them all together to get the average time it takes for the flash drive to fall 1 meter, which I got to be 0.452 seconds. So we can use one of Galileo's equations and plug in our distance of 1 meter and our average time of 0.452 seconds, and when you solve for the acceleration, you get 9.789333542 meters per second squared. And that leaves us with a difference of 0.017316458 between the accepted value and the value measured using this method. The next method we are going to try is similar to the last one, and it's basically the same except that instead of timing the object while I'm dropping it, I'm going to record video of me dropping the flash drive and get the time from the video. And I feel that that should get rid of some of the human error from just dropping the flash drive and timing it. And to make things easier, I'm just going to use the same footage of me dropping the flash drive that I used in the last method. So I imported the footage into Premiere Pro, and I know that the video is filmed at 30 frames per second. So I counted the number of frames that it took from the time I released the flash drive until it hit the ground, and here are the numbers for that. Then I averaged those, and I got 4.87 seconds as the average time it took to fall 1 meter. Once again, I used one of Galileo's equations, and I found that the acceleration is 8.432805299 meters per second squared. And so that's not what I was expecting. But let's try one of the last methods before I explain what I believe went wrong. For the final method, we are going to use this device that my physics teacher, Mrs. Harper, let me borrow for this project. It consists of a little steel ball that, when released from the mechanism, starts a timer, and when the ball lands on the pad at the bottom, it stops the timer. This device is a little older and makes a noise when you shake it, so I don't really know what to expect, so I don't really know how this is going to go, but let's give it a try and see. So before physics class one day, I set the device up and filmed everything so I had the data. So here's the video from all 5 of the trials. It took a few tries to get it working because there was an issue with the timer, that it wouldn't start when you released the little ball, and then other times the timer would just randomly start. So the steel ball was dropped from a height of 0.615 meters, and the average time that it took to drop was 0.3606 seconds. And if you plug all that into the same equation we've been using, you get 9.459183852 meters per second squared for the average acceleration. So the most accurate method to calculate the acceleration due to gravity on the Earth is using Newton's law of universal gravitation. It was only off by about 7 thousandths, and that difference could just be because the numbers we got from Google were probably rounded. Up next, for the second most accurate, was kind of a surprise to me. It was the one where you just drop an object and time it. It was only off by about 0.02 meters per second squared, and I expected it to be the least accurate because there's the possibility of human error when timing. So the third best way was to use the Freefall timer machine. It was off by about 0.35 meters per second squared, and I didn't really expect that much from the machine based on some of the issues I had getting it set up, so I'm kind of surprised that it isn't the least accurate. Finally, this came as a shock to me, but the least accurate method I tried out was using the video and getting the time from it based on how many frames per second it took for the flash drive to fall. So I thought this would be at least as accurate as just dropping something and timing it, but that's not how things worked out. I think one of the issues with the way I tested it was that the frame rate was too low. If I used my phone and I did some slow motion video instead of just filming it on my DSLR, I would have had more frames to see the exact second that it hit the ground, and I probably would have been a little more accurate. So thanks for watching. I hope you learned a little something today, and don't forget to subscribe to Tyler Tech if you aren't already for some more videos like this one.